continue our conversations with Dr. Gita. Today we'll talk more about digital twins, how are they exploring various solutions in the industry and how it's helping various customers. Thank you, Dr. Gita, again spending time with us. So here, quick question on digital twin. Of course, it's now catching up, and many of the industries are coming together to look for advantages of using it. Would like to hear from you. What is probably, we'll start with what is the digital twin, how it's going to take industry to the next levels.
Sure. So I think a lot of people think digital twin is just a buzzword, right? But I think it's much more beyond that. When we talk about disruptions, when they happen, the costs to the companies are huge. A digital twin is something that can prevent such mishaps from happening and therefore save them millions of billions of dollars sometimes. So when you talk about a digital twin, it is not just data in, some modeling and some visualization. People tend to think a digital twin is just data simulation, visualization. A digital twin is much more. A digital twin is something that requires data, of course, that comes in, but it is also something that sends data out. So it's a two-way communication in some sense. Mm-hmm. It closes the loop. Mm-hmm. So digital twin is a living replica of the real world, right? And if something is not working in the real world, then the digital twin can and should set it right. And once that loop closes, that is when we really see the benefits of digital twin. And with advances in communication and computing that we have today, this is turning out to be possible. We have used digital twins, or we are developing digital twins in the space of mobility, logistics, supply chains, warehouses, and of course with early days, but already it's showing great potential and promise.
Excellent. Yeah. So pretty much like the cost of failure is what it comes to the picture when deciding about to have it or not.
Absolutely.
Right.
So planning is one application, but then operations, real world operations, right? That requires in real time for me to understand what is the current state of my system, and if there are any kind of abnormalities in the state of my system, how do I react to it? And that is where a digital twin plays a very important part. Because when we talk about manual interventions, it can take a very long time, and it's very difficult for a person to figure out what is wrong with the system, especially in an emergency.
Just in time solutions.
Yes, it's high pressure, right? And so there is a lot of mistakes, potential for mistakes that are there. But a digital twin is something that can keep listening in to what is happening in my system and then come out with solutions, and not only come out with solutions, close the loop. Right. Give the feedback, actually implement it.
Prevent it in future.
Yes. And then, you bring in the human in the loop if required and say, this is the problem we faced. This is a solution that I'm recommending. Are you okay? When they say yes, the loop is complete.
Very interesting.
So amazing.
The advances in ML, are you seeing any new advancements even in the digital twins?
Yes. So, when we say digital twin, it's not just a single system, right? A digital twin in essence is actually a system of systems, a system of digital twins. Right. Within a digital twin, there are multiple digital twins which are housed in that. For example, if you take your body, right? Every organ in your body is having a function, right? When we talk about digital twin of the body, then you need to have a digital twin of the heart, you need to have a digital twin of the kidneys and brain and so on and so forth, right? So the same way, digital twins are not just one single system, it's actually coming together of several systems, right? And there's been a lot of advancement in ML AI that's being used to model specifics, right? And when these specifics come together, how do they all relate with each other? How do they work together becomes important.
That is true.
And by nature, ML models do not have an idea of the physical world, right? So the physical world has constraints. Yeah. There are laws of physics that need to be obeyed, right? Gravity is 9.814 meters per second square, right? You can't have any other value. So those are things that need to be honored in your modeler, right? And traditional machine language models, we don't build those into it. So now we are talking about world models, right? How do you build AI, ML models of the world? And when we talk about building models of the world, then all the physical constraints also need to be accounted for, right? And this leads to actually a very interesting concept. We talk about digital twins. Now people are talking about phy-gital twins.
Phygital, P-H-Y.
Phy, right?
Physics.
Physics plus digital, phy-gital.
So what is this phygital twins? I heard even in the recent AI summit, they were talking about world models. I heard that. Can you elaborate a little more?
Yeah. So let's say that we want to have an autonomous vehicle, right? So you can train the autonomous vehicle by collecting data, by putting sensors in a vehicle, making it run on the real roads, getting the data, training the model. But in the real world, you don't have extreme cases happening all the time. So when you collect that kind of data, what typically happens is you will collect a lot of boring data, the same kind of behavior over and over again. But what models really need is the edge cases, the long tail, as they say. And getting that kind of data is very difficult and very dangerous.
The outliers and
yes, the outliers. So if you had a physical model, a world model, it will be very, very easy for us to generate those kind of edge case data in the simulation. Right? So you have a world model, you use the world model to simulate these edge cases, and you use the data to train your driving behavior model, right? So that's one example of how a phy-gital twin can be developed. The world model can be applied, right? So there are umpteen examples. If you look at supply chains, there are restrictions in terms of warehouses, there are restrictions in terms of intermodal transfers, right? So we need to capture all of these things into my digital twin. So I need to bring in the physics behind all of this so that I capture things more accurately. Otherwise, what could happen, you may get a very perfect model, but there could be some errors, in which violate the laws of physics. And that could lead to wrong, assumptions and decisions in the real world. And that can prove to be very costly.
Very interesting.
Interesting.
So now I want to switch gears a little bit. Sai, I want to ask you, from your experience, the people talk a lot about digital twins. He gave the technology examples, some good examples, but still companies are a little slow in adapting digital twins. What would be the 3 to 4 business outcomes that companies can use to justify their investment in digital twins?
That's a very good question. See, Tech Mahindra anyway, we've seen this a lot of clients. Interest is definitely there. They're very keen to implement it. But like you said, there probably are initial, the concepts are always there. There are even proven points. But when it comes to the implementation, I think the first thing is obviously the capex. They have to see, the BTU, call it the sensors and all that, where all it can be implemented. And the second part, it comes to the security, right? Is it okay to have so much of data is made available to all the systems, right? But anyway, I would like to probably hear from Dr. Gita later on, right, how it can be prevented. That's second point. And the third, most importantly, is the evolution is happening. And with all the ML models which we thought, right, it can prevent itself, it can learn on its own. All this is evolving. So benefits are clearly seen. In fact, as much as up to 10%, it is clearly shown that the revenues they can scale up, right? They can have the benefits up to 10%. So at a large scale in the industries where they run into millions, the 10% is quite high.
It's quite significant.
It's quite significant value for them. So it's more than the value, I would say, like Dr. Gita was mentioning earlier, one should also be the wary of fact, the cost of failure. Are you ready to, even if not minutes, a day in some cases? I know that if the disruption is there, I don't know, I could talk about it maybe in credit cards. If the world will come to an end, if it stops, right, for an hour, and especially in the scenario of the holidays, imagine that everyone are relying on that, right? And we do have seen cases even in the flights, which comes to an halt when the entire system goes down. So it's all about how much we can take, what is the appetite to have that, how much buffers they have in the business. And I think that really on itself justifies the business case, right? They should really invest in this and make sure that the leverage, especially with the evolving technologies, I think there are a lot of assurance now, the benefits it can bring in. And industry-wise, probably I'll also pick Dr. Gita's brain on what he thinks. See, the adoption, again, it will vary from industry to industry, right? Everyone understands the cost of failure, but for whatever other factors, one is definitely cybersecurity and all that. So what do you think? I mean, what is the way out from here? What is the right roadmap for them? to take a journey into this?
Sure. So yes, data security is very important, right? Every country is now coming up with its own data privacy rules. So we have to honor that, right? Of course, the advantages with advances in AI and ML, we can put adequate security, right, built into the system itself. So any data that need not be visible elsewhere will not be visible. The other thing about the digital twin is it is an autonomous system. So there is not necessarily a human in the loop everywhere. So some of this data is only being made visible within the system, and then it's being hidden, right? Once its lifetime is over, it's immediately removed, and then it's not visible anymore, right? So all of this data pipeline can be constructed in such a way that we honor all the data privacy rules that are there in every country. But yes, one has to be aware of all of this, because a lot more data is generated, a lot more data is being exchanged. So we need to think about this right from the beginning. As you're building these models, at every step, are we honoring, right, all the data privacy laws? That's something that has to be built into that. But it's not an impossible problem.
So long the awareness is there, the know-hows are there. Perfect.
Absolutely, right? So that's about that, right? The other question was about
the adoption part, right? Any other things, right, to make their decision easier, right?
Sure.
One is that on the security is one, data and all that. Like you mentioned, so long we know that what to be taken care, it's always possible. And anything else.
Yeah. So I think when it comes to adoption, right, what is now happening is, again, thanks to AI and advances in LLM, right, the interaction that humans have with the systems are becoming more conversational. It's becoming more natural, right? So I believe that the future digital twins would actually speak to whoever the user is. So it's not even just a visualization.
Capturing, but also converse.
Yes, it's a conversational system, and that will completely bridge. So you don't need to be an expert, right? You could be a layman, and you can actually let the digital twin know that you're a layman, right? So converse to me as a layman, and then take your conversation from there.
Brilliant. So maybe just to take an example in semiconductor world, right? They will look at the temperatures in a room. If it is not right enough the atmosphere, it might even ask, I see a risk with this, would you like to switch it off or reduce the temperature?
Absolutely.
Right. So then you can take a call.
Yes, right. So I believe there will be these AI agents which form a bridge between the digital twin and the users themselves.
Correct. So Sai, I also see two difficulties companies see in the adoption of digital twins. Firstly, in the area of logistics, there are many parties involved. So you have to have a buy-in from different parties. If you have to put sensors, you need a common standard for all of them to operate in. So it's required to have a buy-in from everybody. Secondly, what we also have observed, Sai, many of our clients, they have data, but it's all fragmented data. It's so difficult to bring data to one place. And so data quality, data reliability, data accuracy. So these are some things which we really need to work on to get a good answer.
That's, I think, in AI world it is given.
That is
unless you have the core basic things are right.
Yeah. So I mean, two important points that you mentioned, right? One is the standards. All right. So we need to have standards. Of course, we talked about the Mint Collaborative. So there we are defining standards for digital twins in the mobility world. Right. So logistics is of course part of it, but of course it will take time for people to adopt. We need to have a consensus approach here. We need to have more participants come in, discuss this, right? And it will take time. But that's something that we have initiated some work over here, right? The second question was about
data availability.
Data,
these things.
Yes,
it's garbage
right.
Garbage
Yes. So the data quality issues, right? So again, I believe the AI models, they have an ability to actually understand the quality of data, clean the data, get the data ready, right? So something that would take us hours and hours through manual work is now being done in seconds through AI agents. Yes, right. So the AI models can be trained to identify the quality of data and make corrections if suppose the quality is not good. So that's possible. So with good standards and a layer of AI models that do data curation, cleaning and formatting, we should be able to bridge this gap as well.
Okay.
Excellent.
Also heard of reduced order models. What is that and how would it help in this digital twins?
So, the real world is actually high dimensional, right? So you have, millions of variables, millions of dimensions in which things can change, right? Modeling this is mathematically very, very complicated. So there has been enough work. I'm not an expert in this, so I don't claim to be an expert or know everything in this, but I know that there are others who've been working in this area where they're thinking about how can I replicate this high dimensional model with fewer dimensions, right? And they use some simulation models, they use maybe some heuristics to be able to get equally good results. But there's been, of course, a lot of mathematical advancement in this space. Just because we have the compute doesn't mean we use all of it. We don't need to throw the kitchen sink at every problem that you face, right? I think the future will be how do you develop intelligent models, right? Efficient models to solve the problem at hand, right? Because while we are talking about the AI boom, there is also data warehousing, that is data centers that are actually consuming a lot of energy, and what is going to be the impact, and right. So we need to be intelligent in how we design these models and algorithms ground up, so that we are being very efficient, especially considering energy, considering emissions, right, into perspective. And that's where I believe these kind of reduced order models could help a higher order system solved with much smaller.
Use them in a wise way, and absolutely. And as they say, do your best, rest will be done by models.
That's true, Sai.
Right. So just on the security part, right, I also heard about the zero trust is implemented, where the components within your models will ensure that the validation is happening at every level. So I know it brings in more complexity, but what do you think?
See, earlier this used to be done by a human in the loop, right? So if you're able to get AI agents who can do that, right, that's definitely going to help. Right. Because if you give data that's incorrect, the AI models can give you very, very different results, right? And if there is no supervision, human supervision, then it can lead to big errors and big problems, right? Yes. And therefore, it is needed, right, to have constant checks at different layers to make sure there is data consistency, there is data validity, right? And especially with big data, right? And this is something that would have been impossible maybe 5-10 years back. But with advances in AI and LLMs, I think it is possible to have these checks that is being applied constantly.
The right guardrails.
Absolutely, guardrails on how we implement it. Yes.
Sure.
Well, so in short, we say the replica of this anything which is complex for you, you create that and have that complete governance of it, right, operationally. Then you can take better decisions and simulate it with all extreme conditions so that you can be prepared for it and have your contingency ready and all that.
Yes, right. See, humans are not good at parallel processing.
Right.
Right. We are trained by evolution. We are trained to pay attention to what is important right now.
Correct.
Right. It's a question of survival. Right. But machines are not like that. There is a lot of parallel processing that happens. There is actually multiple machines working together. Right. So we should not project our worldview onto the machine's worldview.
Interesting. Correct.
Right. So if we are solving a problem sequentially, that is not necessarily how machines should also solve the problem. Right. So machines can take very complex approaches to solve the problem. Right. They can coordinate much faster. Right. There is no miscommunication that happens with machines. Right. In humans there can be miscommunication, but with machines miscommunication is not going to happen. So the way we design our systems, the way they network, the way they work together can be very different from how humans work together. For example, in an organization we may have different departments and there may be protocols on how interactions happen between these departments. Those were necessitated by humans working in those departments. Now you're going to have agents and you're going to have systems which are going to do these. You don't need to have the same protocols. Maybe you need a different set of protocols. Right. So we need to reimagine how all these interactions have to happen for this future world. Right.
Very true. I don't know about multitask, even the single task, the one which we used to, for example, we used to do it only with the right hand. If you do with the left hand also we struggle.
Absolutely.
Then absolutely, I agree with you. Thank you so much, Dr. Gita. I know a lot of great insights into what a digital twin and what it can actually bring in the value to the industry. Well, to be frank, we're just quite excited because we've seen a lot of value with all the academia startup world, and we're collaborating with Tech Mahindra and what value we can bring to our customers. And we continue to have this journey, and we'll ensure that all this the excellent work is being done, especially in the world of even digital twins, right? And yes, I'm sure that more than anybody, I think all are winners here, because at the end of the day, the customers also will benefit a lot from this. Thank you again. Thanks for your insights.
Thank you,
Thank you so
Professor
much.
Gita. Thank you.
Thank you for coming over.